So this is a video about making there were some bugs in the strafe mechanics that I somehow got it wrong, how you calculate that. So now I have created these mechanics where I can go forward, go strafe this way, strafe to the side, strafe backwards, go backwards, strafe to the left, and back strafe, and so on. And this controller, and if I move around, it sort of like works like this, and I can sort of like strafe and sort of like move the camera, and sort of like where I'm, as we're shooting at in the video game, and also sort of like move backwards, sort of like away from the camera. So I got this sort of like rather basic controller. So now the question is, like, how did I do that, and what was the error? And the error in in the last video of the tutorial was that I first set the linear velocity up here, and then all the way down here I like set it again, and that ended up the code that ran here up here to somehow set the linear velocity here, then that was basically deleted and overwritten, so I couldn't sort of like make all the code work, because I basically set this box here, set linear velocity, twice every frame. So what I do now is instead I calculate something like the move forward vector non-stop, and it's a little bit difficult to do that in this situation. But what you need to calculate the move forward vector is, you can sort of like do that in various ways. But there is let's see here, it's noisy because I need to lower the resolution to 1080p from like 4K, so it's bitty, so it doesn't make the computer as noisy. So you can search for get direction and actor. There's something called get direction, and the forward vector you get. So I basically get that here, but what's a little bit different is that I decided to split the rotation. You can click here, click to split the rotation, so that some of the rotation happens on, in a sense, the character, let's see here, here this happens on this node, but some of the rotation happens here, right? So notice that if we take here, which is something like the first direction, we saw like rotating around the green value here, right? But if we like look at it like from above, it's actually moving in not the up down direction, but the camera is moving sort of like sideways, right? So it has an effect on the forward vector, not in the up down direction, though I am sort of like rotating about the up down direction. What I'm sort of like, where I'm moving the vector is sort of like along this circle here, or so like you can sort of like see that I'm sort of like rotating the vector in like this plane, or the X and the Z plane. So from the first node, that's called the rigid body, I get the direction of those two, because when I rotate around the Y direction, it's basically the red and the blue that the vector actually changes in, that what I rotate around isn't the same as the vector that sort of like results from that. So when I go in here, I first something like get the direction from this here, depending on like how I have rotated it, this here, and then see, I add it here, and then I unpack that. This is a vector 3, and because it's only this you could say that this here only moves in the it doesn't you see the vector doesn't move up and down. It's sort of like locked in the X and the Z the coordinate grid here. Then I basically only need the X and the Z coordinates. That's the vector. That's all, like that's what changes in the vector when I rotate the rigid body. And then after that, when I rotate this other node here from code, it's the up down that I change. So that's why when I, in a sense, get the direction from that, I only want the effects that has on like the Y coordinate, and then I pack that into the final direction vector, because it's sort of like based on two nodes, because the rotation has been split that way. And then once I have the direction forward vector, if I press W or forward key, I use W for forward, then it sets the forward vector to this. And if I don't press, if this key is false, then it just sets this vector to 0, 0, 0. And what happens then is that before I sort of like set the linear velocity, which is something like the final resulting velocity vector, I first calculate all of these movement vectors for like moving forward, that's here, moving backwards, that's here, strafing right is this math here, and strafing left is this math here. And then I basically have all these vectors. They are like stored in set direction, direction vector forward, direction forward vector 3, direction backward vector 3, direction strafe right vector 3, direction strafe left speed. And then down here I add them all together. So see if we can like draw it. So instead of so the way that I sort of like do it is that so I basically, instead of like just for instance, if I first capture the move forward and the move backwards, let's see. The move I'm sorry, like the move backwards key, and then I set that in the linear velocity, and then after that I calculate the strafe values. Then they are gonna like cancel each other. So if I first input the forward backwards vectors into linear velocity, and then later puts the strafe values in, the strafe values are gonna override the forward backward movement. So I need to calculate what's actually happening, so like the movement direction in all four directions, then add them together, and then finally I will get the resulting vector that I need to sort of like input into so I don't accidentally overwrite some of the calculations later, right? And then there's something that I did here where if we don't do this, there's a box here called normalize. If I don't add this, then notice that that I don't get sort of like smooth directions in the diagonals. If I move forward or backwards or sideways, or in a sense just one normal direction, then it's the same speed. But notice that if I move diagonally or press W and D, I sort of move faster. You see that I sort of like move faster diagonally than I move just front down to the sides. Diagonally, I sort of like move faster. And this happens because I haven't normalized the vectors. Let's just and what that does is that suppose that suppose that I have a vector that goes up here, right? And then I have a vector that goes here. If I add those two together, I will somehow get a vector that's like up here, and that's in a sense the extra speed, you could say, on the diagonal. You can see that this here is actually longer, and that if I draw a circle here, you can like see that what's wrong is that this here vector should only have been this let's see this long, and then it would have had the diagonal. In a sense, the diagonal vectors are a bit too long because they end up being this long, and you need to like cut them down to this length. And there is a function in FLAX Engine called normalize that does this. It basically checks if a vector isn't length 1, then it scales it down to something like length 1, but keeps the same direction. So that's basically what this sort of like box here does. And so let's see here. So if we can like search for normalize, this is rather basic stuff, but it's sort of like how video game engines work, and some rather useful math for like making video games, right? So if we just connect this here, this should make sure that the vectors, also the diagonal vectors, are forced to have a length of 1. So now we have added normalize, and when we move diagonally, it has something like the same speed as when we sort of like move forward and backwards and so on. So now you can see now it's all like, it looks like a bit nicer, right? And that's all like how we do that. And then up here where I calculate the forward movement vector and so on, the way that I do that is, like I said, because I know that when I rotate around the y axis, or one of the directions for these nodes, you can see here I get the direction for the rigid body character, or this here. And if you want to make these, you just sort of like search here for direction, and you sort of like you get the direction here. But then if you want it for the rigid body that only rotates around the y-axis, or something like the middle point here, then you just sort of like drag that in. And if you want it for the other thing that for the other node that the camera rotates around, just sort of like another axis, then you press this and you drag it here, and you sort of like get it here. So that's sort of like how you can like connect these. So you can press Control Duplicate, and you can see here that you can just sort of like connect that here, and connect that here, and that's sort of like how you get the direction from either of these nodes. And you need to add that together because both of these nodes are involved in sort of like the mouse controls, one mouse axis controls this node, and another mouse axis controls this another axis. So you need both of these, or so like what happens here. And then like I explained, because the first node you rotate around the y-axis, then you actually change the x and the z of the direction of the forward vector, so that if you rotate here, it's not in the up down axis, which is the y-axis. This is the rotation axis. But if I want to move the camera up and down, it's sort of like here. But notice when I like rotate this, the forward vector doesn't actually move up and down. You don't change the y coordinate, you change the x and the z coordinate, or these two here technically. So that's sort of like why that code has to be connected this way. And that's how you finally get this sort of where this works, and where this is just basically for each of the directions I calculate that. And if I don't press a button, the particular vector is set to 0. So you can basically say that what I'm doing is that I'm calculating these sort of like let's see here, the forward vector, and then the backwards vector, which is just the negative of the vector. Suppose that this vector here is it has the value of here like 2, and let's say here it is 5. Then this vector here is -2 and -5. If you imagine there is a coordinate grid, right? So this is -2 and -5. So once you have the forward vector, you find the backwards vector by just sort of like multiplying it by -1. And let's see here. And to calculate the sideways vectors, I think I explained that, but you just sort of like you have to like flip some of the numbers. So suppose that you have this vector here, right? And there's like 2 here and 5 here. Then now you can see that now there is a 5 here, and then down here there's -2 here. So that's sort of like the difference, where the 5 sort of like used to be here, and you sort of like just flip some of these numbers. So perhaps it's like a bit more simple to explain another way. But what I ultimately do is I just calculate, this is like forward, this is backward, and so on. This is strafe to the side. And once I have these, I just add them together. So for instance, if I press both forward and backward, I like add these together, and then I get 0, so that if I press both buttons, I sort of like stand still, or as if I'm both going forward and backwards at the same speed, and that just sort of like stops the character. So you get something like a rather simple but useful like a movement controller, right? So that's sort of like how I calculate all this stuff, and you end up with the sort of like this movement controller. For instance, notice that here, like if you take this math that calculates the forward direction vector, basically what I do is I get the same math here. It's exactly the same math, except that I have added this. Notice that the only thing that's missing here is this negate box. So I find something like the negative vector. So so that's basically how. Let's see here. Oops. So basically like this, I just negate that or multiply that by -1, and that's sort of like if I add let's see if I can write this, negate, then if I put this into this vector into this, I get sort of like this vector here, sort of like so the negate box just gives me the opposite vector, as it were. And if you want to find that box, you can just press, you can search for, let's see here, negate, and then scroll down to math, and then it's sort of here, and it just takes like a value. It can, for instance, it can take a float. So if you just like write like a single number, it takes a float, and then you can see that it sort of like returns a float. If you add something like a vector 3, for instance, or a float 3, it's called. You see, this is basically, if you add this, here. If you add this, notice that then the result turns into a float 3. So if you search for math and then negate, you get sort of like a box that can sort of like work with, depending on what you send into it, it will sort of like just return that as the -1 version of that. And then down here, I basically I do the same, but let's see if I can like explain it one last time. Let's see here. If I have a vector here that goes up here, and I want to find the strafe or the sideways vector to that, notice that let's see here. That this value here, let's say that it is 1.0, right? So if you like wanna turn it down here, then you just have to like flip these numbers. So instead it's like 0.1, right? Because now here it's sort of like this is the x coordinate in this direction, and it's I don't know, okay, but you just have to flip the numbers, and it doesn't really matter. It's more something like in principle how these sort of like coordinate grids work. Over here, you basically have to say that the value is 1.-1. So what you have to do is you basically have to change the order of the numbers. And then also, if you want to get the strafe vector, multiply one of them by -1, and then you have the strafe or the sideways vectors. And that's basically what I do here. I don't know if you can see it, but the set goes into the x, and after negating it or finding the negative, the x goes into the set. So that's sort of like how I calculate that. And down here, I'm not sure, let's see here. If here it's sort of like the same, except that it's the set that I negate, and up here it's the x that I negate. Does that make sense? So that was like, I just sort of like I wasn't really sure what was gonna work, so I just sort of like tried until something like worked, and so like then I pressed play, and I was like, okay, so now the math is something like working. Now that it's sort of like it does like this, and I can move backwards, and I can like strafe, and it sort of like works it's supposed to, works the way it's supposed to. And then here it sort of like works the way it's supposed to. And then now I have this sort of like really cool something like a helicopter controller, and that's how I like fixed the bugs in the last tutorials. So I sort of like got this, and I have this sort of like cool raycast laser that I like, I think a few tutorials ago. I can really see if we can push this stuff into the corner here. So that's how you create this sort of like a controller, and that's it. Thank you. Bye.